So it's a beautiful but windy day today, and we've been working on a coop expansion project for the last several weeks. And as I'm working on that project, I realized that we really don't have any backup power for any of our outbuildings or our coop or any of the needs of our animals. And so we're going to take care of that today. We're going to end up installing the BLUETTI EP800 and B500 batteries on my barn to be able to take care of all of my outbuildings, all of my animals in the event that we lose power. So let's get started. The EP800 and B500 batteries are outdoor rated, so we'll look at getting them mounted right over here, and then we'll run power up the wall into the barn and over to our service panel. And then we'll look at installing the included transfer switch and start moving circuits over from my sub panel in my barn over to that transfer switch so that we can, yes, it'll give us the ability to have backup power in the event that we lose grid power, but more importantly, it'll get those loads off of the grid and help us start saving money right away because we'll be recharging with solar. So I got the space all prepped and cleaned up. I got some unistrut added to the wall because I needed something to deal with the ribs on the side of the building. And then the first thing that we need to do is get the different components in place, spaced properly away from the wall, and then fixed to the wall. So we're gonna take that base plate, put it right in place. It's about 5 inches tall, and we need to make sure that it's nice and level. So it's level that way, and it looks like it needs to come up from the front. Now these do have the ability to unscrew, and they have nuts that'll allow the adjustment to stay in place. So we're gonna just kind of loosen these up a little bit, a couple of turns, and then use the nut underneath to lock it in place and check our level again. And now that's perfect. And it looks great the other way as well. And it's nice that it has these little indents for the feet to drop right into so that you know you're right in the perfect spot, seating this nice and snug. Now in the goodie bags for the batteries, there will be the mounting brackets as well as the screws for the mounting brackets and the faceplate. And so we want 4 of these bolts. There's actually a couple different sizes. You don't want the larger one, you want the smaller size. That's what's going to be used to hold the mounting brackets in place. And we'll put the rest back in the goodie bag so that we don't lose them. And so we're going to want to start with these brackets that have the double holes. These are actually going to be mounting to the side of the B500 right down over here. And so we'll get these put on first, and then this bracket will come right on after it, and it'll be adjustable so that we can go right into, in our case, our unistrut. So we'll get these started and then just gently get them snugged up. I forgot, we're gonna need that retaining nut out of the goodie bag as well for the mounting bracket. So we'll need both of these serrated flange nuts, and those will end up going right here and locking in place. So we will put that on and just gently snug it right now because we'll make some adjustments here in a minute. And then I've got 1/4 inch galvanized bolts to go into this unistrut with this locking collar on it. So 1/4 inch bolt as well as 1/4 inch washer. So I'm going to leave these loose for right now just in case I need to make any adjustments. Got it locked in on this side as well. Again, just needs to get snugged down. So we've got everything stacked up. We've got all the bolts in The unistrut, it's nice and tight. It's not going anywhere. It's not going to fall over. I did have to remove the cover here for the AC input and AC output in order to get to this bolt to tighten things down. I then went through and grabbed a 5/16 wrench and tightened down this nut on the sliding bracket to make sure that everything was nice and tight. Now you may end up asking, well, why'd you take the unistrut up above this top unit here? And that's because you can have up to 4 batteries in a stack. And so I wanted to give myself the flexibility if I wanted to add another battery in the future. All I have to do is remove the inverter on top, add the new battery, and then put the inverter back on, and I'll have enough room for that extra battery to give myself close to 20 kilowatt hours of storage. Now, before we do get started with any of the electrical connections, I do need to add that this is recommended to be done by a licensed electrician. I am not a licensed electrician, so do not take everything that I am doing as code. Moving on to the next step of the installation, we need to connect the battery connections between each battery first. So we're going to reach into our goodie bag for one of the batteries, and we're going to pull out the 2 battery connections, and they have these click lock connectors on them. So we'll do the negative first. We're going to pull off the dust cover on the bottom battery, and then the second battery. We'll slide these in between the handles, and we'll lock the bottom one in place, wait for the click. And then you need to have a little bit of a twist on your cable, and then slide in and wait for the click. It must have clicked what I was talking, because it's in there nice and snug. And so we'll do the same thing with the positive side. Pull off the caps, connect the bottom battery first, add a little bend, and then there's the click on top. We'll move up to the next set. And I did forget to mention this, but you do want to make sure that the batteries are all in the off position when you're connecting everything together. Now our top battery connections between the battery and the inverter are going to be a little bit different. We're going to pull this power cable kit out of the inverter goodie bag. And we need to pull off these 2 top covers. In that bag, you're going to see we have the amphenol connector on one end and a lug on the other end. And it also comes with the bolts for these lug connections. Before I make this last connection for the batteries, I am going to put on my insulated gloves. Everything should be off, but you need to be safe when you're working on this stuff. So we'll take our negative line, we'll drop it down, wait for the click, and then we will angle it over so that the bolt can go right through. I will come back in a second with a torque wrench and tighten it to torque spec. And there's our negative connection. We'll come through, remove our positive battery cover, and we'll make our final connection with our positive. And we'll loosely tighten that up. So I'm going to take my 13mm socket. So the torque rating on these bolts is 6 Newton meters, which converts over to 4.2-ish foot-pounds. So I'm going to put 4.2 on my torque wrench, lock that in place, and we will wait for the click. There's 1 and 2. And with those connections made and torqued down, we can put our cover back on. We're going to move to the next step, which is connecting the communication cables. And it's pretty straightforward. They're actually going to daisy chain using these pack link in and link out ports for the bottom 2 batteries. So we're going to have the bottom one. We're going to use this pack link in, and it's a simple twist to pop open. There is a little notch right there that we will line up to the outside. So your cable is going to be like that. And again, we've got a click. Once it locks it in place, we'll feed it up through the handle to this pack link out. So we're going to go from out to in. And this one has the little notch to the right-hand side. push, and we had our little click, and there we go. We've got our good connection, nice and tight, waterproof connection. And we're gonna do the same for the next one, pack link in, and we're gonna go to pack link out. And this is gonna allow for communications between all of our batteries and the inverter. So there we go. We've got those all nice and connected. Now for your top battery connection, the connection that goes from that first battery, your primary battery, up to the inverter, we're going to actually use on the right-hand side of the battery, between the positives, this 2 PCS port. And we're going to go from 2 PCS up to the inverter link port 2. And so there we go. We've got our communication cables going from inverter down to the first battery and then all the way down the chain. Now we need to connect the grounding cables. So in all of our goodie bags, we have a green and white grounding cable. And now the connections for the batteries and the communications were on the left-hand side of the batteries and the inverter. The grounding connections are going to be on the right-hand side. So we'll have to pull out a couple of the remaining bolts out of our goodie bag as well. The larger ones are going to be the ones that connect the grounding terminals from the batteries and the inverter. So the recommended torque on these terminals is 2 Newton meters. So I'm going to take our ground line and I'm going to feed it through the handle, and I'm going to connect this second from the bottom battery first. Just get it loose, and then we'll bend the ground line a little bit so that we can get it into that bottom connection and get it a loose fit. Take our torque wrench and wait for the click. There's 1 and 2. The only difference with the inverter is it actually comes with the screw for the grounding stud, where the others are in your goodie bags. And now the batteries and the inverter are physically bonded together. And then once we make the AC input and AC output connections, there will be a bond back to the main panel. So now that we've got the grounding cables taken care of on this side, we can actually put our covers on. There's 5 screws for each cover, and it really does end up just cleaning it up and making it look nice. So the last thing that I need to do before I could put the faceplate on this side of the inverter is I need to get one of the goodie bags, which contains the IoT dongle. There we go. Got that mounted, and then our IoT dongle is just going to sit right up in there. Comes with this Velcro strap, which is nice. I believe this is supposed to come down through the handle. But we're going into link port 1 on the top. And really, we're done on this side. We've got our PV connections and then our switch here. But we can actually put our cover on this side. And while we're buttoning things up, there are waterproof handle caps for each side. And they have little notches in here, so that's where our IoT line is going to come out. So put that on there and drop it in on this side as well. Well, we've got our DC connections all made with the exception of our PV, which we'll get to in a little bit. We've got our covers on, except for our inverter AC side cover, because I want to switch gears now and start working on our AC connections. We're going to be running 1-inch flex conduit. So you may be wondering, what's the purpose of the junction box? Well, it was recommended by BLUETTI to actually add a junction box here in order to be able to easily make the connections into the inverter, because it's very tight over here. And so using a junction box should give me the ability to flex some line a little bit to easily put the cover on. And then the AC disconnect is required by code for AC coming into the inverter. Now, before we get into Wiring up the AC side, I do want to reiterate that it is recommended to have a licensed electrician take care of all of this. So I've got my glasses on, put my gloves on. The very first thing that you're gonna want to do, you're gonna want to kill the main power. I have already turned off the supply for this in the main service panel in the house. So this is a dead panel right now, but I also wanted to turn off this main breaker just for, peace of mind. And then before we even do anything inside, we will put a voltmeter on to make sure that everything is completely dead. We'll set our meter to AC, and since this is our breaker, our feed breaker, here's our 2 poles. So we're gonna actually put our probes on those to make sure there is no power. 134 millivolts. So dead panel. All right. Very nice. So now let's put our locking ring on this side. And now we've got our 2 panels connected together. Wire requirements for the inverter is 6-gauge wire, which is why we have 50 amp breakers for input and output and the transfer switch, and a 60 amp rated disconnect on the outside of the building. So we're going to start feeding our 6-gauge wire up through the conduit and get it on outside. Well, we got the wire through on this side. It was not that easy. Now I remember why I like using metal and not plastic flex. We can pull that conduit back up into the soffit. So I want to pull it a little tight so that when I go to actually put the fittings over here, I can then push back on the wire a little bit and it'll come back into the box. All right, before I mess with these over here, let's get this tied in inside the barn. And while it's getting in the way, let's strap this. So this is the output from the inverter. So let's trim and connect our ground. Our neutral is going to come up to here, and then our 2 hots will come up to these poles on this breaker. I usually like to leave a little bit of loop on my wire just in case something has to get serviced later. Then we've got our black going to leg 1, and our red will be going to leg 2. Make sure they're snug. So when this breaker is turned on, this breaker has to be turned off, and then output from the inverters will supply power to any of these breakers in this panel. So what I want to do right now is start moving these circuits over to this new panel, and I'm going to try and keep them in the exact same order so that the labeling will be exactly the same. It's just in this panel there were 2 fillers here, so I'll bump these up. So we'll end up having 3 on one side, 5 on the other, and actually there will be a 4th. I'll have to add it later for our new coop lines. But unfortunately I can't find my Sharpie so that I can mark my lines, but I'll put a piece of yellow tape on all my new lines coming in here, so when I find my Sharpie I can come through and just note what each line is, so that in the box with the panel off I don't have to worry about wondering which line is which. So this Reliance transfer switch says that it can support the Siemens, Eaton, Cutler Hammer, Westinghouse, Murray, Square D, Schneider, and GE breakers, which are what I have. If you're getting this inspected, your inspector might want the same brand of breaker in your transfer switch. So just keep that in mind. but I'll just be moving these breakers over into this transfer switch. Go through and turn all these off. And we're going to take out this first breaker, and it's going to go right in the first slot on the left side. And then I've got a spare 12 gauge wire. We're going to feed through our conduit, take off some of the sheathing, and we're going to connect the old wire to the new wire. And I like to put a few twists on them just to make sure that they don't come undone. Since I've got a lot of extra line over here, I'm not going to worry about having a lot of extra line in this panel. So I'm just going to bring it up, snip, trim it, and then reseat it. And so then we just kind of repeat. Pop off the next one, move it over, add your line, wire nut, terminate. Now that we've created space over in this panel, we're going to add a 50 amp double pole breaker that we can run 6 gauge wire from this panel and connect it to this panel. And so this is going to give us basically bypass power, and it's going to give us a connection from our ground bus to our ground bus in this panel and our neutral bus to our neutral bus in this panel. And so if we need to, we can switch off of inverter power and switch back to grid power with everything still in this panel. I actually have two 50 amp double pole breakers. One will be for the bypass coming over to this panel, and one will be for the AC input going over to the inverter. So we'll put one right there, and one directly underneath it. And the AC input from the inverter, when we run this conduit, will just get punched into the side over here and come to this top double pole breaker and then connect over to the inverter. We're going to feed our 4 lines from this panel over to this panel. And these are our connections, our main connections back to this panel. All right, so from this panel's standpoint, we're done in this panel. Got our AC output from the inverter, and then we have our grid feed for a bypass mode. And all our breakers are moved over from this panel, flowing through our conduit. This is our double 50 to supply bypass power to this panel if needed. In a minute, I'm going to go through and pull the wire for this double 50 for the AC input to the inverter. All right, we got the lines pulled through. I have the neutral longer because the neutral is going to be a continuous run all the way over to the side of the inverter. Ground will terminate in here, so will the hots. So our ground will terminate on the ground bus here. Our black will terminate up here, so line comes up here to the top on the left, and then red will be on the right. Well, I think because it's getting late and I'm losing light here, I'm going to have to call it for the evening and then look at finalizing the installation tomorrow. I need to get the AC input terminated in the panel, which I'll probably do real fast. And then tomorrow we'll finish running our lines from here over to the inverter, terminate these connections, get that hooked up, get PV into the inverter, and fire it up. So we'll see you tomorrow. All right, we're back for another day, and we're gonna finish this thing up tonight because we only have a few connections left to make. I went through and added hose clamps where I needed to on the inside and the outside just to button things up. I did have to pull a little bit of extra neutral line through our conduit for our AC input connection because you really need quite a bit of wire sticking out of this box. So inside the AC cable kit bag, it comes with 90-degree terminal connections for your wire to go right into this terminal block. So we'll have to go through, shave off a little bit of the jacket, and fix one to each of our 8 wires that we need to get wired in. So we'll trim off a little bit of the insulation. And I picked this crimper from iWis and have used it quite a bit. So we fit the appropriate die on our crimper, put our lug right inside it just to snug it and hold it in place. Feed our ground line right in just till it barely comes through, and then give it a good squeeze. Nice tight connection there. And then you repeat for all your other connections. So we've got all our connections all done. If I had heat shrink, I probably would put heat shrink on the end, but I had yellow electrical tape readily available. So we need to get the top 4 wires, which are the AC output. Those go to the top 4 terminals up here. The bottom are your AC input, and they go down here. Because of how tight this is, I'm probably gonna have to unscrew these from the wall so that I can move them a little bit and give me a little flexibility. And then once I get these tightened in, all this excess wire is gonna get pushed back into this conduit box and then even into this switch here. So we've got everything all loose right now. So we can move this. So this is actually going to be the easy part. We'll unscrew each screw off of the inverter. Grid comes from the disconnect over here. AC outputs up here. So grid lines coming in. We've got 4 of them. They come over. Here's our 4. Green for ground. L2 is red. Neutral is white. L1 is black. For a backup, our AC output is these top 4. L2 is red, neutral is white, L1 is black, and ground is green. Now we're probably to the hardest part of this entire installation, which is getting this cover over top of this while sliding and pulling these wires back into these junction boxes at the disconnect switch. Screws for our cover. Just get them started in the corners. And you want to make sure that you get this snug because this needs to be watertight, especially if it's outdoors. So we've got everything all closed up over here. Before we go and fire this up though, remember we skipped a step. And that was working with the PV lines and getting the PV lines connected into the inverter. Now, BLUETTI does send a PV cable kit with the inverter. And in that kit, it has 2 male and 2 female connections, as well as 2 MC4 tools. Now, the cable that I have already has ends on the opposite side, but we've got these 2 here that we need to terminate. So we're going to use the included kit and put some ends on it, plug it into the inverter, and then we're ready to go. So we'll need to clean a little bit of the sheathing off of the wire. The red cable, if you have a red cable, should be your positive connection. So our positive lead is going to have this style plug, and if you look really close, I don't know if you can actually see it or not, but there is a plus on this connector, which should help you figure out this is the plug you need to use for positive side. And then we'll have the wide barrel pin, which fits inside this connector. So it's a very simple installation. You will need a crimp tool. I got this one from iWis. You're going to take your pin, and I tend to start the pin in the tool, just so that it holds it in place. Feed your wire in up to the sheathing, and then give it a good squeeze. And it being a ratcheting crimper helps it squeeze down nice and easy. Let go, and you've got a good connection. But there we go. We've got a nice positive connection. And I should have said this before, but when you're working on these wires, you need to make sure that the other end is not connected. So now that we've got that done, now you can take your connector, slide it over top, and you listen for the click. And that actually locks the pin into the connector. Then you can take your two tools. One goes over the nut on the end, the other one slides over the connector, and you're just gonna tighten everything up. This is gonna create a nice watertight connection for you. And you just go until it starts spinning. On the negative side, clean off some wire, feed our connector, or feed our pin into the tool and pinch down. Listen for the click, and start tightening down. Nice and snug. So to check the voltage for the open circuit, and we're going to check continuity to make sure everything's correct. We're going to grab our meter, turn it on, switch to DC. We're going to take our red probe and go into the red line, our black into the black line. This is going to check for continuity and voltage. So right now I've got 3 panels connected. We're at 125.8 volts. Maximum VOC for those 3 panels should be 150 some volts, I think. And we can see that there is no negative symbol, so I have my polarity connected properly. If I had my connections wired backwards, you'll see that negative symbol right there. But because I have things wired properly, we're good to go. Because this is my small array, we're going to be using PV1. And all we need to do is connect right into here. So we turned on power coming into here, but that main breaker is turned off. So we're going to verify power. 242 volts coming from the house into this panel. Everything else is turned off. This is our power going directly to this panel over here. This double 50 goes over directly to the inverter through that knife switch that's on the outside of the barn. This is our grid feed. This is our inverter. Both of those are turned off right now. I am going to turn on the double pole that feeds right here in the main panel. And so I should have power right here, 241 volts. And if I turn this on, then this whole panel will be hot. I do want to leave this open so that I can test here before I supply power from the BLUETTI EP800 into this panel though. But everything else I should be able to close up. I do want to check the power to this knife switch. So the 2 top terminals are my hot terminals. And if I touch my probes into there, 242 volts. So we're looking at page 61 in the manual, step 7 system check. So we went through and we did check a lot of these in our installation checklist. Switch on the DC circuit breakers on the B500 battery packs. Press and hold the power button on any B500 till the indicator on the button lights up green. Turn that on. Turn that on. And there is a tab underneath that you have to use. So you have to loosen the thumb screw and then pinch this little tab in order to get the cover to open up. But it says press and hold on any one of these and it should turn them all on. Green light. Green light. Green light. Wait about 40 seconds till the inverter indicator keeps a steady green. There's our steady green right there. Awesome. Oh, and it just changed to a different shade of green. So this is your indicator on the side. Green for run, yellow for alarm, red for fault. I'm just hearing some different clicks from the inside, probably relays setting and activating. So yeah, step number 4, switch on the AC circuit breakers connected to the inverter grid terminal. That's this thing, here we go. We're still on a green light on the inverter. Now it says power on the system via the app. I just opened up the BLUETTI app. We're gonna hit add device, and it already finds, because of my proximity to the device, the EP800. We're gonna tap that, hit OK. To bind the unit, allow location while using the app, requires location permission. I'm gonna let it utilize my main network. Enter in the password, hit save, and now it's gonna try and connect the BLUETTI to the internet. And there we go. Next, I'm gonna leave the name as the EP800. We're gonna hit start. And now you can see in my device list, I have an AC200L, which is in my house right now, and the EP800 right here. So let's open it up. We're at 32% power. The inverter status is off. Well, it doesn't say anything about powering on the PV, so I'm gonna turn that PV breaker, that PV switch on. And so we're gonna twist that right there to turn on PV. And this system is gonna be powered 100% by solar. I don't want to recharge from grid or anything. I just want it to recharge from solar only. Kind of using the grid kind of defeats the purpose. System switch. Turn the system switch. There we go. I heard a click. And now in the app it says off-grid operation is the inverter status. So we did turn it on. Sweet. We can see that it's pulling from the grid right now to recharge the batteries. I don't really want it to do that. In fact, let's just switch it to self-consumption right now. Wow, I don't know if you can hear that, but the fan is running right now. That was so quiet. The crickets are louder than the fan. Okay, so I switched to self-consumption mode. That way it's not trying to charge from the grid. The manual says, check the output voltage of the backup terminal. We're heading back into the barn again. So we're gonna check the voltage right here, and we are getting 244.6 volts, which is awesome. We're finally here. We're finally to the point where we can actually see if this is going to work or not. I've gone through and I turned on all the breakers in this panel for all of the loads, but both of our breakers on top are turned off. And so just to kind of show you how it works, what I'm going to do, I'm going to turn on the utility side, and then I'm going to turn on the overhead light up above. I'm going to turn off my camera light. So now all that's on is the internal light. This transfer switch has a little lock on it which prevents 2 separate supplies from powering this panel at the same time. Since the grid portion is turned on now, the BLUETTI cannot be turned on. So I'm going to turn off the grid side, and then I'm going to flip this switch and turn on the inverter side, and we should see if the lights come back on. So there goes our grid connection. Grid's out. You see my little green light from my microphone. That's about it. And I'm going to turn on the inverter side in 3, 2, 1, now. And there we go. We're supplying power to this entire panel from the BLUETTI EP800. Yes! That's awesome. Well, we got the EP800 and B500 batteries all connected and wired up, and now my barn and my outbuildings, my animals, all have backup power, so that when we have those heat lamps, or when we have to have the trough heaters turned on in the wintertime, we can have power for taking care of our animals. It's kind of funny, I was talking to my dad yesterday about this installation, showing him a picture of how far I had gotten on the install. And he looked at it and he's like, wow, that actually looks like a backup system for normal people. Because he's seen my basement with my other installations. And he's like, so who would use something like this? I said, really, anybody that would want like a Generac style backup system for their home that doesn't want to use natural gas or propane or gasoline for a generator. And this can work with or without solar panels. You could use it for saving power on your energy bill if you've got time of use for paying higher rates on your electric bill. You can program this inverter to take advantage of using battery power when your rates are higher, and then using grid power when your rates are lower, and then recharge the battery when rates are lower if you don't have solar. Lots and lots of different options. This install from the unit side was probably the easiest install I've ever done. The AC side's as complicated as you really want to make it. But the DC side, I mean, the DC side literally took 5 minutes to get done. I think it took longer to mount this to the wall than it did to actually hook up the DC side. So I was extremely surprised at how fast that is. But this now means that I have, 7,600 watts of power available to my barn and my outbuildings, and just shy of 15 kilowatts of battery storage. So in a future video, I'm going to be looking at doing some load tests with this system. Let's see how well it does when we have to run some of these larger loads for my outbuildings. If I wanted to run a little portable air conditioner in my shop while I'm working on some power tools, can it do it? Can this stuff run my shopsmith saw? That's a big saw. What about some of the heating elements needed for the water trough or the heated buckets? You know, all those little things that really I need power for in the wintertime. I can't afford to lose power. So we'll be taking a look at those in a future video as well. So it's been fun. Hopefully you've enjoyed it. And with that, I'm gonna let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later.